Near the ocean's surface, biology operates by familiar rules. Sunlight fuels the food chain. Animals rely on rigid, calcified skeletons, and most species navigate using standard visual systems. We have mapped distant planetary bodies with higher precision than our own oceans, knowing more about the lunar surface than the deep sea floor. This diagram shows the depth zones of the pelagic ocean. Once you drop below the 200-meter mark, those standard rules of biology begin to shatter. As we descend deeper, sunlight vanishes, temperatures plummet, and hydrostatic pressure climbs to levels that crush traditional cellular systems. To survive the crushing abyss, life has evolved into warped forms that look truly terrifying to the human eye. These adaptations are sophisticated biomechanical solutions designed to overcome the extreme physical barriers of the deep. Between 200 and 1,000 meters, we enter the Twilight Zone. With sunlight fading to a faint blue glow, survival forces organisms to become illusionists. The glass squid navigates this layer using ghost-like transparency, rendering its body nearly invisible against the dim oceanic background. Other species use counter-illumination. They cover their bellies with light-producing organs, generating a glow that perfectly matches the sunlight filtering down from above. This precise light matching erases the animal's silhouette, allowing it to vanish from the view of predators hunting from below. Plunge past 1,000 meters, and we reach the midnight zone, a realm of absolute darkness and fleeting food sources. The stoplight loosejaw navigates this void using a unique evolutionary weapon, a red bioluminescent searchlight. Because most deep-sea prey cannot perceive the color red, the loosejaw can illuminate its targets without revealing its own position in the dark. The loosejaw's mandible also lacks a floor. Eliminating skin between the jaws reduces water resistance, allowing the trap to snap shut with lightning speed. In a zone where visibility is zero and prey is swift, manipulating light and stripping away unnecessary anatomy are the only ways to avoid starvation. The midnight zone presents a significant mathematical problem, finding a mate in a vast, dark, and sparsely populated void. The ceradioid anglerfish solves this through sexual dimorphism. Tiny dwarf males track females exclusively by scent, using a highly sensitive olfactory system. This diagram illustrates sexual parasitism. The dwarf male bites into the female, physically dissolving his face to merge his body with hers. Sacrificing his eyes, fins, and autonomy, their circulatory systems permanently fuse. He becomes a guaranteed sperm bank, nourished by her blood forever. Below 4,000 meters lie the abyssal plains. This freezing desert is sustained by the slow drift of marine snow, or a rare sinking whale carcass. Life here often turns to deep-sea gigantism. Giant isopods and colossal squid grow to massive sizes to conserve energy in the cold and deter the few roaming predators. Under conditions where food and mates are nearly impossible to find, bodily fusion and supersizing serve as hyper-efficient evolutionary answers to total isolation. Past 6,000 meters, we enter the Hadal Zone, tectonic trenches where the hydrostatic pressure is hundreds of times greater than at the surface. If you dropped Mount Everest into the Mariana Trench, its peak would still be submerged by more than a mile of water. A human's rigid, calcified skeleton would splinter instantly under this weight. Yet the snailfish thrives at the very bottom. The snailfish utilizes a biological workaround, a cartilaginous skeleton and a gelatinous body. It functions like a biological stress ball, safely deforming under pressure rather than resisting it. To survive the ultimate physical crush of the planet, life has abandoned rigidity and learned to yield to the environment. Reaching the ocean floor requires passing through zones of fading light, total darkness, starvation, and crushing weight. The physical traits we perceive as bizarre or alien reflect a rigorous biological pragmatism. These creatures operate with total precision within the most inhospitable zones on Earth, the deepest parts of our ocean. They are the final testing ground for the structural and chemical limits of life.